Hi students, I've had some volume problems tonight, so I'm really sorry that the audio is kind of crappy on this video. In the last video we did U substitution and we did them for indefinite integrals, and now we're going to do U substitution for definite integrals. With definite integrals you have a little bit of flexibility. I talked about this U substitution as sort of translating, so you're taking your original function, which is, let's say, given to you in English, and you're translating it into French. So you're making your U substitution, you're making the whole integral speak French. And then when you're done, because the question was asked in English, it would maybe be kind of rude to answer in French. So we translate our answer back to English so whoever asked the question can understand it. With definite integrals, we can do it the same way, or we also have an option of teaching our limits of integration to speak French. And if we do that, then we don't have to worry about English anymore. I'll show you both methods. So I'm going to call option 1 the double translation method. This is translating into U and then translating back into, in this case, R. So the first step is the same either way. The first thing you want to do is figure out what you think U was before the derivative happened. And it looks to me like it would be really nice if my U could be this whole expression. U equals 13 minus R squared. Okay, so if that's going to work, then remember the r's will all cancel. So if I take a derivative, I get du is equal, du dr is equal to negative 2r. So dr is equal to du divided by negative 2r. Okay, so now I'm going to do this double translation. I'm going to ignore the limits of integration at first and just look at this as r over the square root of u times du over negative 2r. It's really good news that the r's are canceling, so everything is now speaking French. I don't have any more English to worry about. And now I'm going to do my antiderivative. And when I do my antiderivative, I add 1 to the exponent, so I have u to the 1/2 times 2. And so now I'm going to make my translation back into English. So my answer is currently speaking French. Normally it would have a plus c, but this is actually a definite integral. And so I'm going to change it back to English. So it's going to be negative square root of 13 minus r squared. And I'm going to use my limits of integration that also speak English. And then I plug my numbers in. So I have negative square root of 13 minus 9 plus the square root of 13 minus 4. So square root of 4, so negative 2, plus the square root of 9, so 3, and so I get 1. Option 2 is kind of like teach the limits of integration French. We're still going to go about it the same way. Initially, we figure out what u is, we do our u substitution, but now when we look at this, we're going to start here. That is negative 1/2 u to the negative 1/2 du. We're going to make this into a definite integral. And currently, the limits of integration 3 and 2 are r coordinates, and I would like them to be u coordinates. The way I will teach them to speak French is I'm going to remember that u is equal to 13 minus r squared. So the French word for r equals 3 is going to be u equals to 13 minus 3 squared, or 4. And the French word for 2 is going to be 13 minus 2 squared, so it would be 9. So I'm translating my limits of integration so that they are in the language of u's. They are now u coordinates. And now when I do my antiderivative, I will not translate it back. Make sure if you choose this option, you don't do a double translation because that your limits of integration would not understand the original language anymore because now they speak French. So our antiderivative is negative root u, and we're going from 4 to 9. So we have negative square root of 4 minus negative square root of 9, which would be 1. Both methods should give us the same answer, right? You have to be aware of this second option when you have a definite integral. Occasionally there'll be a multiple choice question that says, if this integral is expressed in terms of u, what does it look like? And the limits of integration would be changed then. You don't have to use that method if you prefer option 1 and prefer doing a double translation. Just make sure you don't mix the two methods. You wouldn't want to do a single translation but use the limits of integration that were given to you because those are our coordinates. And you wouldn't want to do a double translation and then also translate your limits of integration because then you'd have a mix of languages. All right, so that's how you do definite integrals with u substitution. Thank you so much.